So with these absolute versus relative MRSGSs, it's helpful to see more than one level of these things, that is, more than one term being followed in order to process this with the labels and all that good stuff. So let's take a look first at mod 3, where we have just the 0, the 1, and the 2. And let's first look at the absolute system, wherein, remember, 0 is always in this direction, 1 is always in this direction, and 2 is always in this direction, no matter which direction we happen to be facing at the time. Okay. So now, this is the origin which we'll represent with this empty braces. Yeah, so just the empty sequence, if you will. And then we have 0 in this direction, right? And then 0, 0 would be over here. So 0 and then 0. And if our sequence instead was 0, 1, well, it would be 0 and then 1. Right? So a trail would be this shape, right? This vector, then that vector. Or we would end up here at 0, 1. Right. Cool. And then 0, 2. Let's just say, so we go to 0 this way, and then 2 is this way, because it's always that way in the absolute system for mod 3, RSGS. And so we have 0, 2. And so on down the line. So, 1 would be this way, but 0 is still this way, no matter which direction we're facing, even though we're facing this way. So it's 1, 0, or 1, 1, or 1, 2. And then down the line, if we start with a 2, and then we have, say, 2, 0, then that's 2, 0. We have 2, 1, right, for the sequence, just two-term sequence, maybe not the most amazingly interesting sequence. But we have 2 and then a 1, right? And then we have a 2, then a 2. And that's the idea. Switch that to the relative mod 3 RSGS. So still mod 3, still unit of distance. Now, instead, however, remember the 0 is going to be this way if we're facing this way. 0 is always going to be the direction that we're facing. And then 1 and 2 will be the counterclockwise options from there, depending on which direction we're facing. So still we have the 0, 0 going this way. But let's look at it more interesting to start. We go from the origin here, again with the empty sequence. We have 1 and then 0 would be this way. Or 1 and then 2, as such. Right. I suppose I should start with 1 and 1, or continue with 1, 1. So 1 and then 1, and then 1, 2. There we go. And so on down the line. So we have a 2 and then a 0 is now going to be the same direction that we're facing, which is this way. So it'll be 2, 0. And then from there we could say, well, what's 2, 1? Well, 2 and then 1. That's 2, 1. What about 2, 2? Well, 2, and then we're facing this way, so 1, 2 is now this way. So 2, 2. Right. So that's the basic difference between the absolute and the relative systems in mod 3 RSGS systems. And now we can look at that more in terms of the modulus of 4. It's possibly a little more comfortable to look at. But yeah, so we have 0 is the same, 1 is the same, 2 is the same, 3 is the same every time in the absolute system. And so if we go, say, let's do a sequence 1, 2. So, well, we turn to 1, that's this way. And then 0, 1, 2, so it's this way. So 1, 2. Remember, that doesn't depend on which direction we're facing in the absolute system. And so that's the idea here. Now let's just keep going, because it gets more difficult to follow, perhaps, when the directions keep changing, depending on which direction you're facing. So it's arguably harder to follow when you're looking at a relative system. At any rate, when you're keeping track of everything, like this here, for example. So let's just take a look at, say, 1, 2 here. Well, we're facing this way to begin with, 0, but then now 1 is this way. And now our direction of 0 is this way. So if it were 1, 0, we'd just be here. However, we said 1, 2, so this is going to be 1, and then, so this is 0, 1, 2, right? So now notice we come back in on ourselves, right? So 1, and then a 2. End up back at the origin here. Right. So yeah, that can happen. More on that in a bit. But yeah, so let's take another example. How about say 2, 3, the sequence 2, 3. Well, we're starting with 0 this way, but then there's 1, 2, and then 3, so we're starting 2. And so we have 2, comma 3, so this is 0, 1, 2, 3. All right, so our sequence 2, 3 lands us here. All right. And so that's the idea. Yeah, these this is mod 5, the absolute mod 5 MRSGS. I'll leave this to you if you want to pause it and follow this. It's the same idea. In this case, in the absolute, the 0 will always be this way, 1 will be that way, and 2 this way, 3 and 4, those directions. If you really want to challenge yourself a little bit more, maybe try pausing this and then check, see if you can follow along. But yeah, this is the relative, variation of the mod 5 RSGS, where 0 is facing this way initially, but then it's going to face whichever direction you're facing thereafter. Right. And so you can follow along through this whole thing. It's all labeled, so you can check to see if you're getting it or not. But yeah, I've already explained the basic gist of it, so I won't bother everyone with who might be watching this with all the details. Feel free to do that yourself if you'd like. And then yeah, things get even more interesting as you go into more than just 2 terms of a sequence, of course. And so this is if you really want to go further, try doing 3 terms. Maybe I'll do one for you here. Let's just do the sequence. Let's see what this is. Mod 3 absolute system MRSGS. So let's do a sequence 0, 1, 2. Why not? Okay, so this is 0. It's absolute, so this is always 0. So anyways, 0. And then we have a 1, so that'll be 1 now. Right? And then now 2 is in this direction. Right? 0, 1, 2. So 0, 1, 2, and we made ourselves a triangle, 0, 1, 2. So that can happen, a little loop, if you will. Let's do one more. Okay, so let's just say, let's just travel along a path and then figure out what we did from there. So let's say we went this way, so that's a 1. And then now 0's this way, 1's this way, 2's this way. So let's say we went, let's do this way. So 1, 2. Cool. And then now we're facing this way. And instead of making a triangle, let's do something different. Let's go this way. Okay. So what did we do? Well, tracing back here, we did a 1, then we did a 2, and then we did from here. This is 0 now. I'm sorry. Absolute, you gotta be in the absolute. This is always 1, so 1, comma 2, comma 1. So 1's always this way, absolute, doesn't change. So sorry, switched over to relative for a second there. But yeah, 1, 2, 1 is the sequence that would be the path of that. Yeah. Now notice you actually end up with these other ways to get here. So let's take a look at that. If I traveled 2, 1, 1 instead, I should end up at the same place. So hopefully this is correct. Let's see. 0, 1, and 2. Okay, so far so good. So going this way. And then 1 is always this way. Okay, and then 1 is always this way. So yeah, 2, 1, 1. Now this is an interesting topic. You'll notice, in fact, 1, 1, 2 works just the same in the sense of which point you end up with your, vector laying on here. It's sort of a point sublattice within this whole thing, but don't worry about the details of that. The idea here for just fun here to notice, you can actually permute, if you will, reorder the terms of your sequence and end up at the same place. And this isn't something we're going to dwell on too much, but I just wanted to point that out. It's kind of neat. Now, another neat thing about this whole absolute versus relative systems notion is that, for example, in the with the Fibonacci sequence, in this case we're looking at the Fibonacci sequence mod 18, in both the relative and absolute systems, in this case we have the relative in white, the graph of the Fibonacci sequence over relative mod 8 RSGS in white. And notice when we switch over to the absolute in blue, it looks suspiciously similar. Yeah. And in fact, we can see it's just a slight translation, almost, yeah, of the other one. And so this is by the way not exactly common. If you just change willy-nilly from the relative to the absolute graphene systems of a given modulus for a given sequence, this just merely translating the graph thing doesn't always happen. But it is here with the Fibonacci sequence. Even a more elaborate graph, such as this one. Now these are the graphs in white and blue for the Fibonacci sequence mod 100, and the white's for absolute, and the blue is for the relative graphs. And notice, if you look carefully, you will see that these two graphs are just, one is a translation of the other, even despite the complexity of them. And so again, it's not something that you will expect if you look at just other arbitrary sequences and then just switch between absolute and relative graphene systems, and yet it is occurring here for the Fibonacci sequence. So yet another really neat property in terms of the MRSGSs anyway, of the Fibonacci sequence. We sort of learned to expect that from the Fibonacci sequence, though. And just another example of that, this is with mod 180 from the absolute and relative. And again, this is Fibonacci sequence mod 360. One is a translation of the other from the absolute and the relative systems. So yeah, absolute, relative, they're both interesting. They're both arguably very straightforward implementations of the rather very straightforward MRSGS idea, where you always have a unit of distance and a unit of turn, and that's it, right? Every time, all the time. And so in the absolute system, again, it's always each direction, remains the same no matter which direction you're facing. Whereas the relative system, everything else the same, except now 0 is the direction you're facing at any given time. So that's about that really for now on the whole absolute and relative notions in the MRSGS sort of concepts.